Okay, everyone, let's begin then. So we started talking about function transformations in our last session. We started with started by understanding the three different transformations that we need to know about. First of all, we had reflection, and then we had translation, and then we had stretch. Now, for reflection, you only will have two types of reflections: reflection in x-axis, reflection in y-axis. Reflection with x-axis is the line of reflection, or reflection with y-axis as the line of reflection. These are the only two types of reflection you would have. Okay. Translation. Now you could have horizontal translation, vertical translation, or a mixture of those two, as in both of them at the same time. That can happen. Stretch. Again, you have two types of stretch: vertical stretch and horizontal stretch. These are the three different types of transformations. Vertical, right? So both possibilities are there. They could be horizontal or vertical. This is how we decided that we would have to describe transformations. For reflection, we have to write down the line of reflection. For translation, we have to make sure that we write down the translation vector. And for stretch, we have to write down the direction of stretch, vertical or horizontal, and then also write down the scale factor along with that. All right, so that's how you describe these different transformations. You have to use exactly these same phrases that I discussed with you in the last session. For reflection, you have to make sure that you write down the line of reflection. For a stretch, you have to tell whether it's vertical or horizontal, or you can say if it's along y-axis or parallel to y-axis. Similarly, along x-axis or parallel to x-axis. This is exactly how you should write it down. Okay, any one of these three different options you can use, along with the scale factor, right? So you have to write down the scale factor along with that as well. That's what we discussed. And then we talked about how those transformations are connected to functions. So there are two types of transformations in functions. One, vertical transformations. Vertical transformations mean that the graph is going to move vertically. The y coordinate on the graph, that is going to change. The y coordinates of the points on the graph, they're going to change. And how do you identify that the transformation is vertical? Whatever function you've got, whatever function f of x you've got, vertical transformations happen when you have some operations applied outside the function. So you might have some number multiplied outside, something being added or subtracted outside, and maybe multiplication with negative sign outside. These are the three different possible transformations you could have. We talked about each of them. Multiplication by a number outside means it's a vertical stretch. Multiplication by negative sign means it's a vertical reflection. That means line of reflection is x-axis. And plus minus something, that's vertical translation. The graph moves vertically upwards or downwards. And for that, we have to make sure that we write down the translation vector as well. Okay, so that's what we talked about. Then we talked about horizontal transformations. In horizontal transformations, the graph moves horizontally and the x coordinates change, and you have some operations applying inside the function. So you have some operation applied on x, right? So you could have some number multiplied by x, you could have some number, some negative sign multiplied by x, or something added or subtracted to x. All right, now in this case, in horizontal transformations, things work a bit counterintuitive in the sense reflection is easy to understand, as in we have horizontal reflection. That means the line of reflection is x-axis, is y-axis, sorry. But for stretch and translation, if you have some number multiplying, the scale factor is going to be reciprocal of that. And if you have some number being added plus something, that means the graph is moving towards left. If you have minus something, that means the graph is moving to the right. If you have x plus something, that means the graph is moving left. If you have x minus something, that means graph is moving to the right. Okay, that's what we discussed in the last session. And now, before we start attempting some of those questions that I asked you to do, there's one more thing that you need to know about, and that is how to figure out what is going to be the correct order of transformations. So for instance, let me write that down here on the next page. So we need to talk about order of transformations first before we can start attempting some questions. How do you figure out which transformation to do first, which transformation to do second, if you have multiple transformations? Let me write down some examples here. Let's say you got something like this. You have y equals 2 into f of 3x, right? You have a function f of x that becomes 2 into f of 3x. So the original function was y equals f of x. And after transformation, what happens is it becomes 2 into f of 3x. Now, what transformations are happening here? You have vertical stretch because there's a multiplication outside, and there's a horizontal stretch, there's a multiplication inside. It's a vertical stretch with scale factor 2. It's a horizontal stretch with scale factor 1 over 3. Now, how do we know if we should do the vertical stretch first or the horizontal stretch first? Which one should we do first? Does that matter? Does it not matter? If it matters, then which one should we do first? How do we decide that? That's the question. All right. Similarly, if you had something like this, if you had y equals minus 4 f of x plus 1. Now, what transformations do we have here? We've got vertical reflection, vertical stretch, vertical translation. How do we decide which one of them we're going to do first? Similarly, you could have something like this. You could have a function y equals f of minus 6x minus 2. Again, you have 3 transformations. You have horizontal reflection, horizontal stretch, horizontal translation. How do you know which one of them to do first? And then you could have all of them in a single function as well. Something like this, maybe minus 6 into f of minus 4x plus 1 minus 2. What if you had something like this? You have all 6 transformations applying in this case. You have vertical reflection, stretch, and translation. You have horizontal reflection, stretch, and translation. Now, where do we start? Which one do we do first? So all of these functions, we need to understand how to decide what transformation to do first, what to do second, what to do third. That's what we need to understand. All right. So that's what we mean by order of transformations, the order in which we should apply transformations. Okay. Now let's try to understand what the rule for this is going to be. Let me write that down here. So there are 3 different possibilities that you can have. One possibility is that you have a horizontal transformation and a vertical transformation. So maybe one horizontal and one vertical. So the very first example that I wrote here, you have one vertical translation, one vertical transformation, one horizontal transformation, vertical stretch and horizontal stretch. Which one of these two should we do first? When you have vertical and horizontal, in this case, you say the order does not matter. You can do any of them first and it will be all right. You can do horizontal first, you can do vertical first, it does not matter. Why? Because horizontal transformations only change x coordinates, vertical transformations only change y coordinates. Now, since they are affecting different things, it does not matter which one of them you do first, you're going to get the same result at the end. Okay, so when you have one horizontal, one vertical, you could do any of them first. Okay. The problem is when you have multiple vertical transformations and multiple horizontal transformations. We need to see what happens in that case. So let me write down the case where you have multiple vertical transformations, let's say. Multiple vertical transformations. So what happens in vertical transformations? Some operations are applied outside the function, right? Some operations are applied outside the function. So you could have something like this, f of x, you could have something multiplied outside, and then maybe something added or subtracted outside, maybe plus 3 like this. These are vertical transformations, right? What three transformations do we have here? We have a vertical reflection, vertical stretch, and vertical translation. Which one should we do first? Now, remember BODMAS or just DMAS, division, multiplication, addition, subtraction. So multiplication and division are done first, and addition, subtraction are done second. That's what the general rule is when we multiply and divide numbers, right? In vertical transformations, the same order applies. So division and multiplication, so this is multiplication minus 2, right? This is being multiplied. This is supposed to be done first, and then 3 is 3 supposed to be added second. Okay. Now, what does minus 2 represent? Minus represents vertical reflection, 2 represents vertical stretch. So what that means is, in vertical transformations, you first apply stretch and reflection. Now, stretch and reflection, between them, it does not matter which one you do first, but it has to be stretch and reflection first. And then after that, you apply translation. So in vertical transformations, the order is you first do stretch or reflection and then do translation. All right. Now, what about vertical horizontal transformations? What happens in that case? Now, let me just change this. So now you have multiple horizontal transformations. What about horizontal transformations? Now, you should have guessed. Remember, everything happens the opposite way in horizontal transformations, right? When you add something, you go left. When you subtract something, you go right. When you multiply by something, scale factor is reciprocal of that. It's the same with the order of horizontal transformations as well. And that is, in horizontal transformations, you first apply translation. That's the first thing you do in horizontal transformations. Then you do stretch or reflection. So in horizontal transformations, if the form looks like this, remember this is the standard form in which it should be f of minus 5x plus 2, let's say. This is the standard form, right? F of minus ax plus minus b, right? If it's in this form, translation is going to happen first, and stretch and reflection are going to happen second. So in horizontal transformations, it works the other way around. So that's what you need to understand about the order of transformations. When you have horizontal and vertical, between them, it does not matter which one you do first. You can start with horizontal or vertical, and it would not matter. If you have multiple vertical transformations, you first have to do stretch and reflection and then do translation. If you have multiple horizontal transformations, in this case, for instance, you would first do translation and then do stretch. Okay, so when you're applying transformations on a graph, you will start with translation and then do stretch and reflection. Okay, and the logic for this is the same as what we discussed when we were understanding stretch in horizontal transformation and also horizontal reflection. Basically, what happens is we think of it the same way, that let's say you have f of x equal to something. Let's say f of x is equal to y, let's say. Now, if we wanted, so you have one function f of x, this is what we start from, let's say, and you have one function which is f of minus 5x plus 2. In the original function, let's say if we have x equal to 10, what does that give us? That gives us f of 10. Now, in the transformed function, how would you get f of 10? What value of x would you have to input for that? Inside you want 10, right? So for that, you say 5x plus 2, that should be equal to 10, right? Now to find the value of x that you have here, the first thing you have to do is you have to subtract this 2 on the other side. So it goes on the other side and it becomes 10 minus 2. So you first are applying this translation, right? 2 units to the left. And then you divide by minus 5, and that gives you this value of x, 10 minus 2 over minus 5, that this is the value of x at which you would get f of 10 from this function. Okay, so basically, when you do horizontal transformations, you first have to apply translation and then stretch. That's roughly the logic of this. But at the end of the day, you need to remember this now. You need to memorize this order. In vertical, translation happens at the end. In horizontal, translation happens in the beginning. Okay, that's what you need to remember. So that's about order of transformations. Okay. Now let's look at these examples that I wrote here. What do you think about the first case? 2 into f of 3x. Which transformation should we do first, which second? Anyone?
It won't matter which you do first or second.
It does not matter, right? Because we have one vertical, one horizontal. Between them, it does not matter. So we can say we have two transformations. You can say one is vertical stretch with scale factor 2. And the other is horizontal stretch with scale factor 1 over 3. Now, in this case, it does not matter which one of the two you do first, because one is horizontal, the other is vertical. Between them, the order does not matter. It could be in any order, okay? And that will be okay. All right. What about the second one? Now, this is minus 4 into f of x plus 1. So stretch has to happen first, stretch and reflection, and translation has to happen second. Okay. So first of all, we can say it's, so number one, we can say it's a reflection or a stretch, or we could actually combine these two like this as well. We could say it's a stretch along y-axis, or you could just write vertical stretch as well. That's perfectly okay as well. Vertical stretch with scale factor -4, right? So scale factor -4, it basically does both of those things together. It reflects the graph and also at the same time it stretches the graph, right? So -4, you could write this as a single transformation like this. That's a vertical stretch with scale factor -4, this thing. And then you say the second transformation that you do after that is a translation. Now for a translation, you need to write down the vector. What's the vector of this translation? The graph is going to move vertically, right? It's going to move 1 unit up. X component is going to be 0, Y component is going to be 1. This is the translation that we have, 0, 1. All right. What about this one now? F of -6x minus 2. Anyone, what do you think? What should we do? What's the first transformation? What's the second transformation?
First is -2, then stretch of -6, -1/6. Translation +2, and then stretch of -1/6.
Yeah, that's very good. Now for translation, you have to make sure that you write down the vector. You have to do translation first, right? You have multiple horizontal transformations. In horizontal transformations, if it's in the standard form, you start with translation. Translation is 2, 0. -2 means you're going 2 units to the right. So it has to be +2 in the vector. And then number 2, you do stretch. You could say this is horizontal stretch, or you could say it's stretch along x-axis. It's horizontal stretch. With scale factor. Reciprocal of this number, which is -1/6. Okay. And then what about this one? minus 6 into f of minus 4x plus 1 minus 2. Now you have vertical transformations and horizontal transformations. All possible transformations are happening in this on this particular function. Now, which one do we start from? Do we start from vertical or horizontal? It does not matter. You could start with any of those first. Okay, you could start with horizontal or you could start with vertical and it would not matter. All right. So let's start with vertical, let's say we start with vertical transformations. So first of all, we have this minus 6, right? So minus 6, what's that minus 6 doing? So in vertical transformation, stretch has to be done first, right? So we say this is stretch along y-axis, or you can say vertical stretch with scale factor negative 6. And then number 2, you have this translation. And what's the vector of this translation? The graph is moving 2 units down. So that means it's 0 and minus 2. Okay. And then number 3, you have these horizontal transformations. Now, in horizontal transformations, translation has to happen first, right? So now we first do translation. We could say this number. What is the translation going to be? It's plus 1. So the vector is going to be minus 1, 0 because the graph is going to move 1 unit to the left. And then finally, we have this stretch. Number 4, we have a stretch. It's a horizontal stretch along x-axis. Horizontal stretch with scale factor, reciprocal of this, which is minus 1 over 4. These are the 4 possible transformations that you can have here. This is one possible order. You could also start with horizontal transformations first and then do vertical, and that will also be perfectly okay. That's also acceptable. Okay. Now, in this case, you could actually write it as 3 transformations as well, because you have these translations happening one after the other, right? So it is possible to combine these two as a single translation. If you wanted to do that, you could do that. You could write it as translation minus 1 minus 2. So 2 and 3 could be combined in this case. Now, they could only be combined because there's no other transformation between them. If there was another transformation between 2 and 3, then we could not combine these translations. But if they are together like this, if the 2 translations are together like this, then we can combine these translations like this. Okay. So this is how the order of transformations works. Any problem with this?
Yes.
Yes.
We don't put the reflection part in the minus 6.
Sorry, I can't understand. Can you please speak a bit loudly?
So why didn't we do the vertical reflection? Because we did only vertical stretch.
Yeah, so you can do that as well. So it's just a more concise way of writing this. Vertical stretch with scale factor negative 6. You could write it as a reflection. You could write it as a reflection in x-axis, reflection in x-axis, or you could say reflection with x-axis as line of reflection. A reflection with x-axis as the line of reflection, and then a stretch, vertical stretch, you should write it fully. Vertical stretch with scale factor 6. So this stretch with scale factor negative 6 that we've written here, it could be split into 2 parts like this. You could say it's a reflection with x-axis as the line of reflection and a vertical stretch with scale factor 6. And that is perfectly okay. You could do that. All right. But you could also just write it as a single stretch like this with scale factor -6. So you don't have to write it as two separate transformations. This is a more concise way of writing this in this case. Okay. Any problem with this?
No, sir.
All right, now let's have a look at some of those questions that I asked you to do. Let's start with this first one. This is from May, June 2020, paper 1, variant 3. Let's try this. Okay, it says in each of parts A, B, and C, the graph shown with solid lines has the equation y equals f of x. The graph shown with broken lines is a transformation of y of x, y equals f of x. What we need to do is we need to state in terms of f the equation of the graph shown with broken lines. So this is the original graph, y equals f of x. This goes to this broken lines graph. What transformation is applied on f of x to get that transformed graph? That's what we want to figure out. So first of all, can you understand, just by looking at it, what transformation is this? Can you describe that transformation? It's pretty straightforward. It's a reflection in y-axis, right? The graph is reflected in y-axis. So y-axis is the line of reflection. Is that horizontal reflection or vertical reflection? Do we call this horizontal reflection or vertical reflection?
Horizontal.
Horizontal reflection, because the movement of the graph is horizontal, right? The graph is moving horizontally. X coordinates are changing. So when we have to write down this equation in terms of f, what would you write? If the original function was y equals f of x, the reflection in y-axis, horizontal reflection, means you have to multiply by negative sign inside the function. So it becomes f of minus x. Okay, it's a horizontal reflection. So negative sign is multiplied inside the function with x. Make sense? All right. Okay, let's have a look at the next one now. Now it says, state in terms of f the equation of the graph shown with broken lines. Now, can you figure out what transformation this is?
Vertical stretch.
It's stretch, right? Now, you have only 3 transformations in your syllabus. You have stretch, reflection, and translation. Now, remember, reflection and translation, in both of them, the size of the figure, that does not change, right? The size of the figure remains exactly the same. It's only stretch in which the size of the figure or the shape of the figure, that changes. Okay. Now, in this case, you can see clearly the size of the diagram is changing. This was the original f of x. This is the transformed function. Now, think about it. The width of the function is the same as before. That is not changing. It was 2 initially. After transformation as well, it's 2. What about the height of the diagram? So this height is 2 units, originally. What happens after transformation? This height becomes 4 units. So from 2, it goes to 4. So what do we say? We can say it's a vertical stretch with scale factor 2, right? Because the y coordinates have multiplied by 2 in this case. So it's a vertical stretch with scale factor 2. Now, how do you write down the equation for this? Vertical means you have to do something outside. You have to multiply by a number outside. So it becomes 2 times f of x. That's the equation that you would write here. That's the graph shown in broken lines. Y equals 2 times f of x. Okay. Now, let's have a look at this. What about this? What transformation is this now?
Translation.
This is translation. The graph has moved from one place to another place, right? This is translation. Again, for our own understanding, we can write it on the side first. What translation is this? The graph is moving. So take any one point. So let's take this point, for instance. The graph is moving towards left and down. How many units to the left is the graph moving? It's moving 1, 2, 3, 4, 4 units to the left. So we say the translation vector is going to be -4. And what about vertical movement? It's going 3 units down. So it's -3. That's the translation vector, which tells us that the graph is moving 4 units left and 3 units down. Now, what about the equation of this graph? Y equals f of what? That is what we need to figure out. So we'll have a horizontal transformation and a vertical transformation, horizontal translation and vertical translation, right? Both of them are happening here. Translation is when you add or subtract something. In horizontal, you have to add or subtract something inside. In vertical, you have to add or subtract something outside. Now, what exactly should we add inside or subtract inside? What exactly should we add or subtract outside? So what about outside? Vertical translation. You're going three units down. What does that mean? Outside the function, we should have a -3, right? Because -3 means the graph is going 3 units down. What about inside the function? Yes, Naima? What about inside the function?
Plus.
Why plus? +4, because it's 4 units to the left. In horizontal transformations, it's the other way around, right? So left means that you have to add something. And when you have something being subtracted, that means you're moving to the right. Since you're moving to the left here, inside, you are going to have plus. You have +4. That's the equation that we've got. F of x +4 -3. That's the transformation. Make sense? Let's have a look at another one now. So this is from November 2020, paper 1, reading 3. Okay, let's try this. In part A, they just ask you to express x squared plus 6x plus 5 in this form where a and b are constants. Now, the first part is just a simple quadratic question. You have to complete the square, right? So you have x squared plus 6x plus 5. How do you complete the square for this? You first make the coefficient of x squared 1. It's already 1 in this case. Then you say it's x squared plus 6x. You add 3 squared to it, and you subtract 3 squared from it. And outside you've got plus 5 as it is. Now these 3 terms give you a perfect square, x plus 3, and that becomes x plus 3 whole squared minus 9 plus 5. And the completed square form turns out to be x plus 3 whole squared minus 4. That's the completed square form. That's the first part of this question. That's all that we have to do here. Now, what about part B? In part B, it says, the curve with this equation, y equals x squared, is transformed to the curve with this equation. Y equals x squared plus 6x plus 5. This is the transformation that is happening. Now we need to describe fully the transformation. What transformations are happening from x squared to x squared plus 6x plus 5? How do you figure that out? Can you figure out what transformation is this? Are we adding 5? Does that mean 5 vertical translation? Are we multiplying x by 6? But why is this x not being multiplied? How do we understand this?
You can use the completed square form.
Yes. So in quadratic functions, in order to understand what transformations are happening, you would always need to complete the square. Otherwise, you would not be able to understand what transformations are happening. So in quadratic functions, always complete the square first. Okay, let me write this down here as well. In quadratic functions, always complete the square. Now, in this case, they asked you to do that in the first part already. If they had not asked you to do that in the first part, you would have to do that anyway in the second part, because otherwise you would not be able to understand the transformations that are happening. In quadratic functions, always complete the square to understand the transformations that are happening. Okay, this is important, because otherwise you can't figure out what exactly is happening to x squared. Now, we have already completed the square in the first part. What we've done is we have basically converted this to this form, x plus 3 whole squared minus 4. Now, looking at this form, it's pretty clear now what transformation is happening. The function was y equals x squared. So what exactly are you doing? You're basically adding something inside the function, right? The function is x squared. Inside, with x, you are adding plus 3. And outside, you are subtracting minus 4. Okay, outside the function, you have negative 4. Okay, so inside you've got plus 3, outside you've got minus 4, right? Okay. All right, so x plus 3 whole squared minus 4, this is the transformed function. Okay. Now, these are both translations. You have plus 3, that's a translation. You've got minus 4, that's also a translation. Inside means it's a horizontal translation. So one transformation that's happening is horizontal translation. How much is that? You're moving 3 units to the left. So the vector for this is going to be minus 3, 0. And the other translation that's happening is minus 4. That means 4 units down. So that's 0 minus 4. Or you could write it as a single transformation like this. You could say it's a single translation. You could combine both of them and say it's minus 3 minus 4. That's the translation that you've got in this case. Make sense? Any
Yes,
problem with this?
No.
Okay. Now you can see in the question it says, describe fully the transformations involved, and S is inside bracket. That means it could be a single transformation. It could be multiple transformations. Both possibilities are there. So you could write it like this, as 2 separate transformations or as 1 single transformation. Both will be acceptable. Okay. So what's important to remember from this is that in quadratic functions, you have to make sure that you always complete the square to understand transformations. Okay, now let's move on to the next one. This is March 21, paper 1, variant 2. Let's try to understand this. Okay. So you have this diagram. The graph of x, y equals f of x is shown with solid lines. You can see that here. The graph shown with broken lines is a transformation of y equals f of x. Now, they're basically asking us to describe fully the 2 single transformations. So now they have told us that it's 2 transformations that have been combined to give the resulting transformation. So they have to be 2 transformations that take us from f of x to this transformed function. Now, what are those 2 transformations? Let's try to figure that out. Now, remember, we talked about this. The size of the figure only changes in case of stretch. Is the size changing? It is changing. So there has to be a stretch here as well, right? There has to be a stretch. So that's something that's easy to figure out. All right. So you should start from that transformation that is obvious or that's straightforward to figure out, start from that one. So you can see it's a stretch, right? What stretch exactly? Can you tell me what stretch it is?
Vertical stretch with the scale factor of 3.
Vertical stretch with scale factor 3.
3.
Because you can see horizontally, the width of the figure is not changing. It was 2 initially, and it's 2 after transformation as well. Vertically, it was 1 earlier. After transformation, it becomes 3. So 1 is going to 3. It's getting multiplied by 3. So you say you have a vertical stretch. So 1 transformation is a vertical stretch. Now just write it down for now, for reference. We also need to take care of the order later on in case that matters. We'll see. For now, just write it down on the side that, okay, this is 1 transformation that is definitely happening, that it's a vertical stretch. And the scale factor of that stretch is 3. Okay, so that's 1 transformation. We will write that down. But what other transformation is happening now?
Translation.
Translation. Okay, and what's the vector for that? What's the vector of the translation? Sorry?
4, 0.
4, 0? Okay, does everyone agree to that? 4, 0? Any other guesses? Any other possibilities? Isn't the graph moving vertically as well? So should the y component be 0? Does that make sense?
It's not moving. It's not moving. It's not moving vertically because it's being stretched already.
Okay. So that's good. Any other ideas? Anyone who's thinking of maybe 4, 2?
4, 1, 2.
4, 2?
Yes.
Yeah. Anyone else who thinks it's 4, 2? Or maybe 4, 4? If you think about maybe these points, this point is going here. Okay, so one common answer to this question is, as in what candidates end up writing down, is 4, 2. So you think, okay, it's going 4 units to the right. The graph is moving 4 units right. For example, if you look at this point, for instance, it's moving 4 units right, and then it's moving 2 units up, and say it's 4 right, 2 up, and you could write it as 4, 2. But then if you consider this point that it's moving 4 right and then 2 up, what about this point? How much is this moving? This is moving 4 units right and 4 units up. So which one is it? Is it 4, 2? Is it 4, 4? Or maybe none of them? How do we decide that? Basically, once you have figured out one transformation, what you should do is, you should draw an intermediate diagram that, okay, after this transformation is done, where exactly this diagram would be. Now, let me explain what that means. So instead of writing it down directly like this, because that's going to make you do errors, what you should do is, you've already figured out that there has to be a vertical stretch with scale factor 3. Now let's see what happens if we were to stretch this diagram, stretch f of x by a factor of 3 vertically. Where will this graph go? So this point is 1 unit. This is going to be here. It's going to be 3 units away. And then what about this point? This is 2 units from the x-axis. Remember, in vertical transformation, we have to look at the distance from the x-axis, right? This point is 2 units away. This goes to 6, right? The point at 2 goes to 6. And the point here, this is also 2, the y coordinate of this, that also goes to 6. So basically, the transformed diagram, okay, I'm sorry, it's not this. The other point was actually, okay, so the middle point was here, and then the point on the right side is here. After you do the stretch, this is what the diagram is going to look like. So after you've stretched the graph vertically by a factor of 3, this is what you're going to have. So stretch is already making this graph move upwards by a few units. So this point moves 2 units up, this point moves 4 units up. So stretch basically handles vertical movement already. Now, how do you go from this graph to this graph? You only have to go 4 units to the right. Now you can look at any point, any corresponding point now. So this point goes this here, that's 4 units to the right, or you can say this point goes here, that's also 4 units right. So now after that stretch has already happened, you only have to go 4 units to the right. So the translation that you have here is just going to be 4, 0. It's not going to be 4, 2. It's not going to be 4, 4. It's going to be 4, 0. Okay. So that's what we write here now. It says describe fully the two transformations that combine to form this, to give this resulting transformation. Number 1, you have vertical stretch with scale factor. It's better to write it in full like this. Scale factor 3. And number 2, we have a translation for which the translation vector has to be written. You can't write in words that the graph is moving right or left. This word translation is necessary, and the translation vector is also necessary. What's the vector? 4, 0. That's what you would write. Now, since one of these transformations is vertical and the other is horizontal, even if we were to reverse the order, it would not change anything. We would still get the correct result. So in this case, the order does not matter. You could do it in any order. So these are two transformations that we have, because one is vertical, the other is horizontal. The order does not matter. Now it says, state in terms of y, f, and x, the equation of the graph shown with broken lines. The original graph was f of x, right? What transformations are happening to f of x? There's a vertical stretch with scale factor 3. That means we multiply by 3 outside. Vertical means you have to do something outside the function. So you have 3 multiplied outside. And this is horizontal translation. 4, 0. What does that mean? 4 units to the right. In horizontal, that means inside the function, you have to subtract something. So it's x minus 4. That is what the equation of this function is going to be in terms of y, f, and x. Does that make sense to everyone? Okay. No problems?
No problem, sir.
Okay, let's have a look at the next one then. This was March 21, paper 1, variant 2. Let's try the next one. Okay, so this is the next one that we have. It says, find the translation. So they've told you that it's a translation. Find the translation that transforms the graph y equals 5 over x squared minus 3x to the graph y equals 5 over x minus 2 whole squared minus 3x plus 10. What transformation takes you from this graph to this graph? This function to that function? Let me actually write it down again because it's, I think, slightly unclear. 5 over x squared minus 3x. This is supposed to be transformed to 5 over x minus 2 whole squared minus 3x plus 10. Now they have told us that it's a translation, okay? It has to be a translation. Now, what is going to be the vector of this translation? What's the translation vector? How do you figure that out? What's the translation vector? Anyone? Any ideas?
Minus 1 over 4 and 10.
Minus 1 over 4? 1 over, where does that come from?
1 over 2.
minus 1 over 2 and 4 and 10, sorry. Okay. Where does minus 1 over 2 come from? Are you taking reciprocal of this? It's a translation. Reciprocal was in stretch when you had to write the stretch factor, scale factor. In that case, we used to take a reciprocal. Where is minus 1 over 2 coming from?
Because it's in a fraction, so I said, so I separated it.
No. So remember, the transformations work like this. Whatever the function is, if you have f of x minus 2, what that means is x is replaced with x minus 2. Wherever in the function x appears, you're replacing that with x minus 2. All right. Now, in this case, x is appearing here. So x is being replaced with x minus 2. What does that mean? What translation is that? Minus 2 inside, that means you're going 2 units right. So the horizontal component has to be 2. Does that make sense? The horizontal component has to be 2. Why? Because it's clear from the function that if you had f of x originally, instead of x now, you've got x minus 2. Inside the square, instead of x, you've got x minus 2. So that takes you to this function, f of x minus 2. This is a horizontal translation 2 units to the right. So the horizontal component has to be 2. Okay. Horizontal component has to be 2. Okay. Now, what about the vertical component? So you're saying it should be 10, right? Because you have 10 here. 10 is being added to the whole thing. So that makes you think that this is 10, right? Now, does everyone agree to that? That it should be 210? Any other ideas? Can you see the problem with this, with 210? Can anyone tell me why it should not be this? Think about it. Figuring out the...
It's not in completed square form.
It's not in completed square form. Well, that's not necessary in this case because it's not a quadratic function. Remember, it's not the standard quadratic function form. Quadratic function looks like this: ax squared plus bx plus c. You have all the terms in the numerator. This is in the denominator, and you already have kind of a square in the denominator in this case. But here we don't think of completed square form because it's not a quadratic function as such. Yes, you see x power 2, but that's actually x power negative 2 when it comes to the numerator. So that's not a quadratic function. All right. So that's not the problem. Think about it. X is going to x minus 2. Inside the square, instead of x, we've got x minus 2. So that makes it very clear that the horizontal translation is 2 units to the right. So this is kind of obvious, right? X is changing to x minus 2. But the problem is, if x is being replaced by x minus 2, why is this x not changing? When we do f of x to x, when we go from f of x to f of x minus 2, this x should also have been x minus 2. Why is this x not changing? Basically, what happens is, when you do this transformation, when you go from f of x to f of x minus 2, the result that you get after doing this step is going to look like this. After this step, this function 5 over x squared minus 3x, this is going to go to 5 over x minus 2 whole squared minus 3 into x minus 2. That is what should happen when we do a translation of 2 units to the right. Okay. Now, just doing a translation 2 units to the right already gets us to this point. If you were to simplify this, this basically gives you 5 over x minus 2 whole squared minus 3x. Now, what they've done here is they've simplified this thing. Instead of leaving this as x minus 2, they've simplified this and written it like this, 3x plus 6. So basically, after doing this first transformation, the resulting function that you get is this. So this horizontal translation of 2 units to the right already gets you to this point. And now what you need to do is, from this point, you have to go to that final function, which is 5 over x minus 2 whole squared minus 3x plus 10. Now, how do you go from plus 6 to plus 10? How much do you need to add more to this? In order to go from 6 to 10, you have to add 4 more to this, right? So you have to add 4 more to this function. Now, let me write that down here as well. Once you have already gotten to this form was f of x minus 2. Now, in order to go to this form, what you have to do is you have to add 4 outside this whole function, because 6 is already there now. After that horizontal transformation, we already have 6 here. In order to go from 6 to 10, you need to add 4 more only and not 10. So what's the vector then? The translation vector, therefore, should be 2 and 4 and not 2 and 10. That's the final result that we get from this transformation. Make sense? So instead of 2, 10, it's actually 2, 4. So again, the idea is the transformation that is easy to figure out, you start with that. So in this case, it was quite straightforward to figure out that x is changing to x minus 2, right? That's pretty obvious. So the horizontal translation is supposed to be 2 units. So what you should do is you should just apply that transformation first and then see what result you get from that. So after doing that first transformation, you already have this result. And then you see, okay, from this point, how do we get to the final result? You have to add 4 more outside the function. So that means the vertical translation is supposed to be 4. Make sense?
Yes, sir.
This was quite tricky. Figuring out the horizontal translation was straightforward, but not figuring out the vertical translation. Okay, let's have a look at one last question before we end. This is from March 2022, paper 1, variant 2. Now, transformation questions you will only find in recent papers because this was only added to the syllabus in 2020. So that's why we're just doing these recent questions. Let's start with this. The last question for today. So we have to express this quadratic function in the form 2 into x minus a whole squared plus b. Now, this is kind of the completed square form, but not exactly the standard form. Remember what the standard form used to look like? It was a into x minus h whole square plus k. This constant was outside the bracket. Now, in this case, this constant that they've given, that's inside the bracket. So it's a slightly different form, okay? Now, let's see how we can get to this form. You just apply your standard process of completing the square. You have 2x squared minus 8x plus 14. How do you start? First of all, you take 2 common outside. When you take 2 common outside, that leaves you with x squared minus 4x inside. Then you have plus 7. Add 2 squared and also subtract 2 squared. And that gives you plus 7 outside as like this. Now, the first 3 terms give you a perfect square. You have x minus 2. So that becomes 2 into x minus 2 whole squared. And then this minus 2 whole squared, and this minus 2 squared, that's minus 4 plus 7. Remember, the square is only on 2. Minus is outside the square. So the minus sign is going to stay there. And that simplifies to 2 into x minus 2 whole squared plus 3. That is what they wanted to convert this, wanted us to convert this function to. Okay. Now, if you had to convert it to standard form, you would multiply this 2 inside like this, and it'll become 2 into x minus 2 whole squared plus 6, but that's not what they want. They want this form in which this constant is inside the brackets. So you'll just leave it like this. That's your final result from the first part. Okay. So that's the first part done. Let's have a look at the second part now. Now it says there are two functions. One function is f and the other function is g. And we need to describe fully a sequence of transformations that maps f of x onto the graph of g of x, making clear the order in which the transformations are applied. So it's important to write the transformations in the correct order. All right, so that's important. Now, how do you do that? Let's think about the two functions that you've got. You have to start from x squared, and from x squared, you need to go to 2x squared minus 8x plus 14. Now, this is a quadratic function. Remember, in quadratic functions, we need to have the completed square form, first of all. Do we have the completed square form? Well, we don't have the standard form, but we have this form, right? Something very similar to that. Let me write that down here. That is 2 into x minus 2 whole squared plus 3. This is the form that we have converted this function to, this expression to in the first part. Okay. And now we need to go from x squared to this thing and tell what transformations are applying here. Now, one possibility is that you use this same form that they made us convert this expression to in the first part. You use the same form as it is. Now, using this form, can you tell me what transformations are applying? You have a horizontal transformation. Horizontal transformation is when you are changing something with x, right? So instead of x inside the square, now you have x minus 2. That's the only horizontal transformation that we've got. So you could start from horizontal. Remember, we could start from horizontal or vertical. It does not matter. You could start with any of them. If you start with horizontal, we could say it's a translation. 2 units to the right. This is what this minus 2 represents. Okay, so that's a horizontal translation. What vertical translations, what vertical transformations do we have? We have a vertical stretch and we have a vertical translation. These are the two vertical transformations that we have. Okay, we are multiplying by 2 and we are adding 3. Which one do we do first? Do we do stretch first or translation first? Do we start with stretch or translation?
Stretch.
Stretch. Because it's a vertical transformation. In vertical transformations, we generally do stretch first, right? But that rule was when you had everything in the standard form. The standard form is you have something multiplying and then you have something added. Remember, we said it's the same BOD-MAS rule. Do multiplication, division first, addition, subtraction afterwards. The problem here is this is not the standard form. They have used brackets here like this. So when you have brackets, the brackets have to be evaluated first, right? 3 is inside the bracket. So before you can actually multiply by 2, you have to add 3 here. Before you can multiply by 2, you have to add 3. That means in this particular case, the translation would have to be done first. This translation, you would say it's a translation 3 units vertically upwards. That's 0, 3. And then you would do stretch. That's a vertical stretch. And the vertical stretch is with scale factor 2. But since they have used these brackets here, they are forcing us to do translation first and then do stretch afterwards. Okay, so if you were to use this form exactly as it is, you would have to do translation first and then do stretch. Okay, so this is what it would look like. This is +3. That's giving us the second form, and you have this 2 multiplied, and that's giving us this vertical stretch. Okay. Now, since these translations are one after the other, we could also combine them if we wanted. These two could be written together. We could write them together like this. We could say it's a single translation that has vector 2 and 3. Right? That is also possible. And then you could just say it's a translation 2, 3, and then vertical stretch with scale factor 2. That is one possibility. The other possibility is that you first convert it to standard form. Okay. Once you have the standard form, then you apply the same order that you're used to using. That is the other possibility. You could just do that. Convert it to the standard form. Okay. Now, what's the standard form? You had x squared. That was going to x squared was going to 2 into x minus 2 whole squared plus 3. The other possibility could be that you first convert it to this form. You say it's 2 into x minus 2 whole squared plus 6. Now that's the standard form, right? You have something multiplied, you have something added. Now your standard order for vertical transformations would apply in this case. So I would say this is generally easier to do. Just convert everything to standard form first of all, and then just use the order that we discussed. Now it's the standard order. Now you could apply that order that we discussed. Stretch reflection first, translation second in case of vertical transformations. So now, again, you could start with either horizontal or vertical. It does not matter which one of those two you start from. You could do any of them first. Okay, and that would not matter. Okay, I'm sorry. Let's just write it again. Okay, so first of all, we have translation 2, 0, right? So again, we start with horizontal translation, horizontal transformation. That's translation. In this case, that's 2, 0. So that's the first transformation that we have. And then we could move on to vertical, but now since it's the standard vertical form, we would have to do stretch first and then reflection and then translation. So now number 2 would be stretch here. You would say it's a vertical stretch. It's a vertical stretch with scale factor 2. That's the second thing you do in this case. Okay, so this is the second step. And then at number 3, you would say you have a translation. What's the vector of that translation now? Now it's +6. So you'd say it's translation 0, 6. That's the third transformation that you have. That +6 outside means it's a translation 0, 6. This could be another way of describing the sequence of transformations in this problem. And that will also be accepted. Okay. Now in this case, notice there is a third, there's another transformation between the two translations. So we cannot combine the translations. We can't write the two translations together in this case. As in, this cannot go first here. That would not work because vertical stretches in between. What we could do, yeah, should I mention that? Okay, so I hope it does not confuse you, but you could do it this way as well, that if you start from vertical stretch first, you could do this first, And then the second would be this translation. That will be 0, 6. And then horizontal could be done at the end. That would be 2, 0. And then since translations would be together, then you could combine them to 1, which is 2, 6. That could have been possible. Okay, that could be done. But in this form, if you're doing horizontal translation first and then vertical transformations, in this case, since there's a third transformation between the two translations, you cannot combine them. You have to write them separately. Okay, if you understood what I said at the end, that's great. Otherwise, just forget about that. This is going to work. Okay, you convert it to standard form and then apply that standard order that we discussed earlier. Make sense to everyone? Any problems with this?
No, sir.
Okay, so now I hope you should be able to attempt all the transformation questions from recent papers as well. You should try them. We've done quite a few already. Try some from recent papers as well. I think there are a couple in which there's a circle that is transformed, or something like an oval. That's another tricky question that I saw in recent past papers. Try some more. But now that you understand the concept, you should be able to figure all of them out. All right. Okay, so that's it for today. Tomorrow we are starting our next on Friday. On Friday we are starting our next topic, either APGP or equation of circle. But those are two small topics now, so they should not take that much time. Just a reminder for those of you who are on YouTube right now, I have a past paper session starting from 13th of April. You can find all the information about that in the link that you can find in the description below the description of this video. It's also there in the live chat on the right side. I also posted the answers to a number of questions that I'm getting from students about the duration of the past paper session, about the number of years that we will be discussing, the number of years of past papers that we will be doing, whether we'll be doing complete past papers or just specific questions. I've answered all of those questions on my Instagram. I've posted five, 6 answers to different questions. You can have a look at that. Hopefully most of your questions will be answered by that. You can register using the link in the description of this video. And if you have any questions after looking at those frequently asked questions, you can also post them on my WhatsApp, on my Instagram, and I'll hopefully see some of you there in that session as well. All right. Now, any questions before we end? Any problems, anyone? The early bird discount, by the way, ends on 5th of April. That's just 2 days left. After that, it's going to be standard fee. The early bird discount is going to end on 5th of April. So if you want to register, you can have a look at that link. All the details are available there. Okay, so before we end, anyone, any questions? Any quick questions?
No, sir.
No? All right, so I'll see you again
Right.
on, yes, Abdurrahman.
Write the vertical stretch first and then write the translation. Then we can combine the translation of both.
Yes, in this case, if you started with vertical transformations first, right, with vertical and horizontal, you could choose any order, right? So if you started with vertical, you would write this as the first one, and then this as the second one, and this would be third then. And then since the translations would be together, you could write them as one if you wanted. Okay, but that's optional. You can still write them as separate, and that's also fine. If you wanted to merge them, that's also fine. Okay. All right, good. I'll see you again on Friday then. Allah Hafiz.